Alright guys, welcome to 4.2. This is your warm-up for 4.2. Okay. The warm-up says, what is the difference between domain and your range? Okay. Your domain is the input. What you put in, it is always your X value, and you also read it from left to right. That is a domain. Okay. Your range is the output. It is your Y value, and the way you read that is from bottom to the top, floor to the ceiling. Okay, floor to the ceiling. Now for part 2, it says in your own words, what is a horizontal asymptote? Go ahead and take a moment and put it in your own words. So horizontal asymptote is an imaginary line. In our case, when we draw it, we draw dashes to denote that it's an asymptote. Okay. It is an imaginary line that a function or graph approaches but never cross. Okay, imaginary line that a function approaches but never cross. And since it's horizontal, it is always going to be the Y value. Okay, since it's horizontal, it was always going to be Y value, Y of some sort. So there you have your horizontal asymptote. All right, so let's go to today. We're going to do a little bit of application part. Okay, so for 4-2, this is what we're going to do today. Students will be able to rewrite and analyze the basic form of an exponential equations. Now, if you guys remember, you can write it a times b to the x. You also saw it as a1 plus or minus r to the x. These are exactly the same thing, okay? So if it's a plus, then that means it's a growth. If it's a minus, it's a decay. All right, so that was your basic form. And then let's see. So, exponential equations are pretty straightforward when it comes to writing and graphing them. They stay in the same basic curve and do not change directions. It's also relatively easy to graph accurately based on the equation. So it's either going to be a growth like this, or it's going to be a decay. Pretty much. Okay? Here's the basic form. Y equals a times b to the x. Keep in mind, this is also the same. A1 plus or minus r raised to the x. And sometimes the x is a letter t. A represents the starting amount. B represents the rate of increase, whether it's a growth or a decay. So this would be like, if it's greater than 1, it's a growth. Less than 1, it's a decay. X represents your time. Sometimes we use the letter t, same thing. And Y represents your amount of time. Okay? How long did it take you? Like other equations, you can add to this basic form, but the majority of the problems can be solved with this basic understanding of an exponential equations. All right. Now, what type of functions grow or decay exponentially in real life? Human population, there's a growth, or it could be decay. We have more people dying than being born, or we have more people being born than die. Okay, so that's how you can have a growth or decay. And why is that important? Well, it's called supply and demand. Food, space, land, all those things are important. Another one is animal population, kind of important when they're going to become extinct. Or maybe they, like the boa constrictor, it's inhabiting Florida like crazy. They got to get rid of it because that's not natural in that area. Radioactive decay, radioactive, all that, okay? This one we are going to touch on later, but you are going to have to know exponentials in order to do logarithm later on. Depreciation, accounting, appreciation, growth. Interest, you're good. Economics, percent interest. Are you earning money? Are you losing money? Okay? So let me know all those things. All right. So these are a few of the many examples of exponential functions that we will study. All right. So let's take a look at human population growth. Now remember, here's the formula. I like to use the A, 1 plus or minus r raised to the x. That's the formula I prefer to use, because then I know if I'm going to do minus or I'm going to do addition. Suppose the city has 48,000 people according to the current census data. It is also estimated that there is a net increase of 4% in the population. What do you expect the population to be for the next census 10 years later? All right, so RA is 48,000. Okay. There's an increase. So, an increase of 4%. 4% is the same as 4 over 100, which is 0.04. Okay? What do you expect the population to be in the next 10 years? So, our x is 10. All right. So, here's your r. So, we're going to plug this in. Y equals 48,000. Try not to use a comma when you are writing the equation itself, but when you get the answer, then add the commas then. But try not to, because sometimes it looks like a decimal. It's a growth, so 1 plus 0.04. You see how I use that instead of the letter B? And it's going to be for 10 years. All right, you will need a calculator for this part. So let's take a look. All you have to do, you got all the information you need, so just type it in. 48,000, 1 plus 0.04. You need to convert that to a decimal out of percent, raised to, and here's the caret button that you do raised to, right there, okay, to 10. So how many people do they expect in 10 years? So y is equal to 71051.72568. All right, I'm going to get you guys for this if you don't read carefully. It says, what do you expect the population? So we're talking about the number of people. Can you have 0.72568 people? I don't care if they only have the top half of their body, okay? Can you have that? They're still one whole person. So your answer is 71,051 people. Make sure you label, okay? Because otherwise, what is that number? Is that how much I have in my bank account or how much money I owe? So make sure you label. Number 2, animal population decay. Remember, I am using the same formula every single time, okay? Suppose the population of Atlantic walruses is decaying due to poaching for their tusk. You are tasked with trying to find the consequences of poaching, resulting in decrease of 6% to the population. So your R is 6%, okay? You can write negative if you like. If there are currently 50,000, so that's what I'm starting with, of this species of walruses remaining, how long will it take until there are less than 500? So your Y is 500. Do you guys see that? So I got my Y, I got my A, I have my R. The question says, how long? Okay? So we got to go solve for x. So you have 500 equals 50,000. 1, now it's a decrease, 0.06, okay? Because this is 6 divided by 100 raised to the x. All right, you guys see all that? Okay. The easiest way to solve is to do it this way. You ready? You don't know how to do logarithm yet, so I want you to do it this way. Use your calculator and we're going to estimate the time. Type this into your y equal, okay? So we're going to type it in. Where's your y equal? Let me clear my calculator. See the y equal? So we're going to do it the long way because we don't know how to do logarithm yet. Type this in, just like you see it. 50,000, 1 minus 0.06, raised to the x. Now, the x you use is this x right here. Okay, oops, my fault. Raised to the x. There we go. Okay, type everything correctly. Now we're going to go to a table, second table, and then we're going to look for the y value. Okay, so you're going to look for the y value. And what is that y value we have over here? 500. All right, so we're going to look for 500. See how I'm going down? This might take you a little while, but that's okay, because you don't know how to do logarithm just yet. But if you do, go ahead and do it that way. But we will learn that in the next unit. All right, I'm heading in that direction. So 500 is between those two. And the question says, how long will it take until there are less than 500? Well, if I pick that answer, 74 years, that's still above 500. So the correct answer is 75 years. So x is equal to 75 years. Okay, so we're just going to estimate, and I'm good with that. All right. So again, type in the equation, second table, your y value, go look for the 500. Okay, and this is less than 5, so I got to pick 75. All right. Example 3. Here we go. Interest can be good or bad depending on which side of the coin you are standing. Let's suppose you have 1,000, so my A is 1,000, in a savings bond earning. See the earning? So my rate is 2%, and it's going to increase. And if you want to write a plus in front of it to let you know it's a growth, more power to you. For the next 5 years, so x is equal to 5. And the question says, how much will you have when this period ends? So y equals 1,000. I'm earning, so convert that to a decimal. Okay, x is 5. So I just type that into my calculator. Remember, to get out of this, you hit second mode, second quit, and we're going to type this in. 1,000, parentheses, 1 plus 0.02. You could go ahead and put 1.02 if you like, raised to the 5. Okay, so how much are you going to have in 5 years? This is money, so I need a dollar sign. Dollar sign goes in front. And we always have, in dollar amount, 2 decimal places to the right, so 0.8. Okay, labeling is very important. I will continue to say so. If you just write it without labeling, tell me what it is, I'm going to take points away, because this is an application problem. Okay, let's look at decay, interesting decay. Now for the bad news with interest. Let's assume you have an outstanding balance on a credit card for $1,000. Okay, it has an wow. By the way, that's a very common interest rate for beginners. It has an annual interest rate of 22%, which comes out to be 0.22. Okay, if you don't pay on it for the next 3 years, how much will you owe? So there's my y again. So let's write the equation. So you don't know what that is. So y equal, okay, 1,000, 1 minus 0.22 raised to the 3. Okay, type that in. Now if you want to go ahead and put 1 minus 0.22 and write it as a decimal 0.78 right here, kind of like rewriting it, you can do that. These two are exactly the same, okay? I don't like to do extra work unless I have to, but that's just me. All right, 1,000, 1 minus 0.22 raised to the 3. You are going to owe $474.55. Please box in your answers. I would really appreciate that. All right. Okay, depreciation. Here's another decay problem. Depreciation is a loss of value for something like a car. As soon as you buy that car, the price of value goes out as soon as you sign the paper and you leave the lot, just to let you know. You bought a car for $15,000, there's your A. It is expected the car will lose roughly 10%. Real life, guys, it usually lose a lot more than 10%. How much could you sell it for in 9 years? So X is 9, okay? R is 10%, and you're losing, so you can put a minus in front of it if you like. And A is 15,000. So this is 0.1. Notice it's 10 over 100. So you have Y equal 15,000. I'm losing, so 1 minus 0.1, or you can put 0.9 to the 9. So Y equal, and here we go with our calculator again. 15,000, 1 minus 0.01, raised to the 9. You can sell that car for $13,702.76. And there you have depreciation, okay? Radioactive material. We're going to touch on this in the next unit, so we're going to skip it for right now. And so there you have your assignment. Remember, label your answers, okay? Good luck, guys.